demonstration as well, and that will be a recorded demonstration. So please look over all the communications that I provide for you through email as well as through Moodle so you fully understand the assignments that are coming up. So for us to successfully write an inquiry-based science lesson plan, which looks very different from all the other lesson plans, we need to understand the 6E model. So today we're going to be discussing Chapter 3, Planning for Inquiry, and any other experiments or lesson plans I discuss in this lecture are also posted in this Moodle module. So to begin, we need to discuss what is inquiry-based learning. And I want you guys to watch this video where we watch students developing student-driven questions. And this is the whole point of this lesson plan.
I realize how much more they learn when I see that they take action and they're applying the skills that they learn in here. I feel like I've done my job as a teacher. At your service.
Inquiry-based learning is just a fancy word for curiosity, right? So tell me what child is not curious?
We as humans all question. That's how we learn. So the students should be questioning all the time.
Any questions?
We're trying to ignite passion and relevance. It's not just about finishing that assignment. It's about being able to explore something that I'm really interested in.
The basic steps in inquiry-based learning is to come up with a rich question, a question that doesn't have the answer already in it.
You begin with the questions that you really want to explore in a unit.
And then each unit has lines of inquiry that the students will be investigating. And the lines of inquiry are developed by the teacher, but with a lot of input and feedback from the students.
And that becomes the direction that the teacher takes the content. So the teacher will resource kids with opportunities to explore things that they're interested in within that line of inquiry. So kids are hitting the standards with the bigger questions and being able to create evidence of their understandings and their learnings in all kinds of ways that the kids get to pick.
So for instance, we're doing a money unit right now. We're studying billionaires. The theme billionaires was not chosen by the teachers per se. It stemmed from the students' inquiries. When we were going through the inquiry process and they were asking all these questions, a common theme that kept coming up was, why are some people so rich and other people are not rich? I remember a lot of you were wondering why some people don't have as much money. Remember that? Yeah. Okay, so those questions led to our investigation. We had a huge discussion about why we're studying billionaires, and it's not because they're superhumans or that they're rich or they're cool because they have a lot of money. We were looking at character traits, and we were talking about what do these people have that, you know, enables them to be this successful.
We're doing a keynote about Ralph Lauren's cards. He has a giant card collection. We're asking ourselves some questions, and then we would have looked on Wikipedia and searched up the questions. Maybe one day we want to invent something.
This right here is how Warren Buffett influenced society about what he did, how much money he gave to charity.
How about this one?
Why would I really care about someone donating money to a charity?
Because she helped someone, and then she built a school for girls.
We're opening up learning by letting kids decide, hey, what am I really interested in science? What am I really interested in social studies? What am I really interested in literature? Giving them a whole list of potential things and letting them do the inquiry and research and make those connections.
So if you have a dystopia, you could say that Hunger Games would be one of your resources because it's a fiction story that actually plays out in a dystopia region. Inquiry-based learning actually makes you think, essentially. You're still doing it in the Common Core way, but you're actually picking what you want to learn.
All of a sudden we see our students doing things that really matter to them, and they're excited and they're passionate and they want to talk about what they're learning.
They're inspired. They're reflective. They struggle. That is a true education.
Okay, so now that we've learned a little bit about inquiry-based learning, we're going to get a little bit further into that with our 6 E's. So what exactly are the 6 E's that are expected in your lesson plan? Well, the first one is engage. The purpose of engage phase is to pique our students' interest and to get them personally involved in the lesson while pre-assessing prior understanding. So if we're going to be discussing a scientific phenomenon, it could be the phases of the moon. It could be properties of matter like liquid, water, and gas. You need to know, where are your students coming from? Like, have they noticed that there are different phases to the moon? Do they have some crazy ideas as to where that comes from? Maybe they think the moon's made out of cheese. So those are things that we need to kind of figure out. So the engage section is going to be where we introduce the topic, we figure out what they already know, and we get them excited about learning about that topic. The second E is explore. The purpose of explore phase is to provide students with the opportunity to construct their own understanding of the topic. What you saw in that previous video was these students, they drove the inquiry. They wanted to ask very specific questions. And although you may not be able to allow every single student to explore the question they have, you can do group work and guide them through various things they can explore. And then you have explain. The purpose of the explain phase is to provide students with an opportunity to explain and refine what they've learned so far and determine what it means. Basically, what that means is you're not going to stand at the PowerPoint and you're not going to explain the phases of the moon. You're going to let them figure it out and explain it to you. And then we have elaborate or enrich, depending on whose 6E model you're looking at. So elaborate or enrich, the purpose of this phase is to provide students with an opportunity to explore in more depth what they've learned and transfer those concepts to a more complex problem. So maybe during the explore phase, you had students looking at various household materials to identify if they are a solid, a liquid, or a gas. And then with the elaborate or enrich, you could start discussing maybe the properties of water versus other materials and how they become solids, liquids, and gases. So maybe you can discuss why alcohol doesn't freeze, but water does. Or you could look at oobleck, which is that mixture of cornstarch and water, which acts like both a solid and a liquid. So that's where that elaborate and enrich comes from. Then we need to evaluate, right? Every lesson plan needs to be assessed. So this is where both the students and the teachers determine how much learning and understanding have taken place. And I'm going to tell you right now, next week we're going to be discussing a lot more how we can assess, but I'm going to tell you right now, exams are not going to be the best way for you to assess a lot of this inquiry-based learning. And then finally, the 6E is e-learning. On their own terms, have students continue to investigate and enrich the knowledge with further research. And this might be you applying what they learned to a real world problem or having them investigate specific things. And I have an example later on in this lecture that we will continue to discuss. So planning inquiry experiences. First, we need to start with backward design. Hopefully you guys learned about backward design in your lesson planning course, and if you have not and you have questions, I am happy to Zoom with you all as groups or individuals. But stage 1, you want to think about what are the desired results from your lesson. Stage 2 is assessment of evidence, and stage 3 is the actual learning plan. So we're going to go into more in depth about that, and I want you all to know that your discussion board this week is you explaining to us what the desired results for the specific student learning objectives you've chosen from Louisiana Believes are for your lesson plans. So the first stage is, what are the desired results? This is what your discussion board is going to be about. So what is the specific standard you are addressing in the lesson plan you're designing? What does the class already know, and what skills and understanding are your students developmentally ready to learn? You really need to think about that. Like, if you're teaching first grade, that's going to look a lot different than if you're teaching this concept to a 6th grader. I would have you consider looking at LEAP test questions or the LEAP test for your grade to help you with your planning, because obviously that is how the state is going to assess your students' knowledge base. So if you understand the types of things they expect these students to know about that student learning objective, that will help you identify the desired results you want from that lesson plan. But never teach to the test. What you need to do is prepare your students for that state assessment, but obviously you don't want them to be taught directly to the test because that takes away from that whole inquiry-based lesson planning. So, what do you want your students to achieve as a result of the lesson? Remember that a primary focus is on the children's ability to engage in inquiry, so they need to be driving that lesson. Look at the light unit attached to this model. Each lesson has a specific question it needs to be answered. So for example, if you look at the light module, it's a unit on light. And one of the first lessons the teacher does is, what can you see in the dark and what can you not see in the dark? And so that teacher is trying to achieve the student's ability to understand like what you can see in light versus what you can see in dark. Backward design stage 2, you need to determine acceptable evidence. You need to brainstorm ways that we can know what the students know. What performance tests or other assessments will ask the students to do to see if they achieve the desired results? What can we ask the students to do to know that they understand that student learning objective? So check out the light unit in this module. What specific assessments does the instructor use for each lesson in this particular unit? Is this teacher actually using tests, or is this teacher asking students to present ideas, observations, construct a model? I would say consider using group assessments, consider using individual assessments, look at laboratory skills and abilities to observe and explain phenomena. And we talked a lot about this with our social studies inquiry-based lessons, where we would pose a question to individuals, then maybe do a think, pair, share, then break our students out into groups and have them investigate something together, and then possibly assess them individually after the group work. You could easily apply that same model to a science lesson plan. And then backward design stage 3, plan the learning experience and instructions. This is where you figure out how your students are going to achieve this. Like, what activities are they actually going to do? What resources do I need to supply to my students for success? So if you check out the light unit, how does each activity or resource provided lead to the student successfully achieving that learning objective? Now let's talk about each of these E's individually, and I'm going to briefly go over each one, and then I'm going to apply them to an experiment. Engagement. This is 2 parts. We start with a story to prompt students' prior knowledge and to build foundation for subsequent activities. So this is where we need to pique their interest. Maybe you're going to read a children's lit book. Maybe you're going to ask them everything they know about a particular topic. Maybe they're going to make a KWL chart, or if you watch the video on the next slide in your PowerPoint, because the video is not going to come out very well in this recording, you can learn about the KLEWS chart, which is a lot better for a science activity. And then the actual engagement hook, modeling or having students observe a phenomenon that gets them excited about the learning objective. So you may need to model something, and then you're going to ask them, what would you do differently? How would we test this? What variables do we want to look at in this experiment? And let them start driving the inquiry-based lesson. I like to say this, the I can statements. I can is not inquiry-based. I can is just them stating a student learning objective. You want them to start thinking about, what do I want to investigate? So instead of I can, maybe you want to ask them, I want to investigate blank instead. So this is the video I was discussing. If you go into the Moodle module and download the actual PowerPoint, please watch this video. It's really helpful, and I think some of you are actually going to want to use this method in your lesson plans. The next one is exploration. Learners are in charge of the activity and we are there to guide them. What does that mean? You, as the teacher, you are going to help them develop their experiment, figure out what they want to test, and allow them to test it. You should be moving around the classroom. You should be prompting them to answer questions about their observations. What do you see? What do you think is happening? How did this change from different trials or variables? What do you want to try next? This is not you telling them exactly what to do step by step for the entire lesson. And this is not you explaining why they're saying what they're saying. You want them to develop those explanations. And that's the next step, explanation. This is your time to check for understanding. Ask a variety of questions that guided the elaboration. Try to have a mix of questions that will help focus attention on specific content and skills, as well as questions to expand the thought process. You describe a particular phenomenon. Why do you think that happens? And I'm going to show you a specific example at the end of this lecture that pulls this all together. Next is elaboration. This is where we're going to clear up any misconceptions and ensure our students understand the original concept. So this is where we're going to bring the class back together. And we're going to say, oh yeah, that's a great idea of a way to explain it, but how does that tackle what we already know about solids, liquids, and gases, or what we know about living things? So this is when you need to have them pull together that knowledge that they have and that you've taught them into this. Then identify the students who have achieved the key knowledge and skills through evaluation. Was your lesson planning effective? What are you going to assess? Are you going to assess their actual knowledge, the process or skill that they learned, their attitude of the experience itself? So you really need to think about your assessment. And next week, we're going to go into great depth about some really fun assessments we can use. And I'll be providing you a multitude of methods that you can use in your own lesson plans. And then e-learning. This is the use of technology, and this can be at any point in the lesson. Students can investigate something before the actual exploration. Maybe you want them to find everything they can out about the water cycle before we actually do an activity involving the water cycle. Or students can wrap up an investigation by finding out additional information using the internet. Students can create online presentations or explanations of what they learned. They can create models online or concept maps. These are all ways that you can use e-learning. So here's the example I kept talking about. So there's a lot of lesson plans about dissolving M&Ms to develop a model to describe that matter is made up of particles too small to be seen. So the actual objective that the teacher wants to achieve is students will be able to develop and explain a particle level model to describe their observations of water dissolving the colored sugar coating of an M&M. Students will be able to use this model to develop an explanation of their observation of an M&M in sugar solution. So what are the specific concepts within that objective? The teacher wants the students to be able to dissolve a solid in a liquid and find out that that depends on the interaction between the particles of the liquid or solvent with the particles of the solid or solute. So he's going to teach their students about solvents and solutes, and also that dissolving happens when attraction between the particles of the solvent and solute are strong enough to overcome the attraction of the particles of the solute to each other. So this is when we're going to start talking about charged particles. And just so you know, this does align with our national standards as well. So what are we going to do? Well, step one, we need to engage our students. We're going to ask them things like, who likes M&Ms? What are M&Ms made out of? You can have students look at the colored candy coating of an M&M and ask students to look at an M&M and have a discussion about what they think the coating is made from. And you can do this through a think, pair, share, or a group interview, or you could just have them brainstorm and you're just writing lots of things down on a map. But there's lots of things that you can do. And then after you engage your students in the discussion, let your students know that the candy coating is actually made of mostly sugar with some coloring. And then ask your students if they think the coating will dissolve in water and why. And this is where you can have your students start thinking about experiences they've had. I mean, how many of us have had M&Ms melt in our hands and our hands turn different colors? And so that's probably what they're going to think about. Or if they drop an M&M in a puddle and they see that the colors start to come out. So that's how we engage them. And then you're going to have students observe, and then have students discuss like when they've seen the color coding come off. Then we're going to have our students explore. You're going to have your students place the M&Ms in a room temperature water. You can watch this video to see that. So this is the explore part. This could be you modeling. It could also be them doing this as well. But what I'd like you guys to think about is you now need to have your students writing down their observations of what happens to the sugar and color coating of an M&M when you put it in water. And also this is when you start getting them to think about things. I would take it one more step. Let students come up with different temperatures and different variables for those M&Ms, or start to really think about why this is happening. Then I would explain that water molecules interacted with sugar and coloring molecules in the color coating of the M&Ms and caused the coating to dissolve in water. I would explain that the water molecules, which I'm going to show you a model of in a minute, are attached to two hydrogen molecules. So water is considered polar, which means it has both positive and negative charges on it. And the sugar and the food coloring molecules, they also have positive and negative charges. So remember, opposites attract. So the positive charges on the water would then start to attract the negative charges on the sugar and the food coloring, and vice versa, pulling the sugar and the coloring away from the M&M. So here is that model. One moment, please. And so what we see here is you put your M&M in the water, but when we look at it real closely, you can see here are the color and the sugar molecules. So the color is green and the sugar is purple. And then here's your water molecule. So you see the negative charge and the positive charge, and then we see that also on the sugar and the coloring. So the positive and negative on the water molecules attract the opposite charges on the sugar and coloring molecules, pulling them away and allowing them to get dissolved in the water. I would bring back the key terms solvent and solute at this point. Just so we can reiterate the key terms and ideas. So now we're going to discuss how to design a test to see if an M&M coating dissolves as well in a sugar solution as it does in a water solution. So we can ask our students things like, will an M&M's coating dissolve as well in a sugar solution as it does in a plain water solution? Why? What do we know about the causes of the candy coating to dissolve? Maybe this is where you also let them look at salt water or alcohol or other charged liquids and talk about this concept of these water molecules pulling apart that shell. Now, if these water molecules are already bound up to sugar, then maybe it won't dissolve as quickly, or maybe it'll dissolve more quickly. So these are all things that we want them to do. Then you're going to have them do the experiment again. So maybe they'll do it under different concentrations of sugar or salt. And you can have them do things like time how fast it takes for the colors to dissolve, do the colors dissolve, do certain colors dissolve faster than other colors, and have them hypothesize what they're observing. So then you need to evaluate your students. Can students explain why there's a difference in M&M shell dissolving in sugar water versus plain water? Or warm water versus cold water? Excuse me. Do students fully understand the scientific method? Can students use the correct terminology like solvent and solute and particle? And how will you assess their understanding? Will they do a lab report? Will they do a lab presentation? Are they going to do something online? So those are all different ways that you could do that. And then for e-learning, you could have your students investigate where the colors in these shells came from, or the history of candy coating. Why do we color our candy with bright colors? What other variables could they test? Sorry. And why does the M on M&Ms not dissolve? So I hope that helps you guys with your lesson planning. And I hope you guys have a great week. Thank you so much.